Hi, this is Anil from Computer Science Department, GPCET College of Engineering and Technology. Today, I am discussing data structures Unit 1. The Unit 1, under Unit 1 we are having two chapters. In the first chapter, the topics are asymptotic notations, one-dimensional array, multi-dimensional array, and with arrays. So coming to the topic asymptotic notations. Asymptote means a line drawn between two boundaries. The asymptotic notations are mainly three in number: big O notation, omega notation, and theta notation. In addition to these three, there are two more notations: little o notation and little omega notation. Okay, and coming to the big O notation, it is a method of representing the upper bound of algorithm's running time. Using the big O notation, we can denote the longest amount of time taken by an algorithm to complete. And coming to the second one, omega notation, it is a method of representing the lower bound of algorithm's running time. Using this notation, we can denote the shortest amount of time taken by an algorithm to complete. And theta notation, the third one, is a method of representing the running time between upper bound and lower bound. So the three notations, they are related to the best case, worst case, and average case performance analysis of an algorithm. Big O notation is related to worst case, omega notation is related to best case, and theta notation is related to the average case. And coming to the last two notations, little notations, the functions and the mathematical terms are f of n, g of n, c, n, and n naught. Now f of n and g of n are non-negative functions. C is a constant with value greater than 0, and n is an input data, and n naught is the basic input. The relation between n and n naught is n greater than n naught. The big O notation formula or the condition: f of n less than or equals to c into g of n. Omega notation: f of n greater than c into g of n. Theta notation: c1 into g of n less than or equals to f of n less than or equal to c2 into g of n. In the first two notations, big O and omega, there is only one constant, and in the theta notation there are two constants with that is c1 and c2. Okay, and coming to the second topic, arrays. An array is a finite, ordered, and collection of homogeneous elements. So, coming to the classification of arrays, it is one-dimensional array and multi-dimensional arrays. Now, first we discuss one-dimensional array. So, an array with one subscript is called as one-dimensional array, and the major advantage with arrays, the time taken to execute a program is less when compared with the normal declaration of variables. Examples: int example data type, and array representation is a square bracket, that is our subscript, followed by the variable name, example counts. And in the similar manner, double array representation, variable name, and the syntax: data type, array name, data type, space, followed by the name of the array or the variable name, and within the subscript, the site. Okay. The array elements, they occupy continuous memory location. The array index starts from 0 to n minus 1. Thank you. It is up to the extent of asymptotic notations and one-dimensional array.